Okay. This is a problem we started yesterday, which says find the regression line. And then we read through the problem. We set up what x and y essentially are and named what they were. We looked at the table of data, and then we did something called align the data, which means that I'm not going to use the actual year. I'm going to use a representation of the year. And since X is the number of years after 1998, I looked at 1998. It was 0. 99 is 1 year after. 2000 is 2 years after. 2001 and 3 years after. 2002 is 4 years after. Now that's the data that I'm going to use to graph. That's the data that I would use if I were going to put it into my calculator. We looked and we graphed the data and did a scatter diagram, and then realized it really doesn't look like a straight line. If I exclude that one point, it certainly does, that I could almost put a straight line through it. But I have one point, and we decided, is it an anomaly? Is it something that I would want to check out as to what happened that year? Is the data right for that year? Any numbers of things that can go on. It enables us to ask some questions. But certainly, a straight line would not fit it exactly. And the primary reason is if I were to take 2 points, draw a line through it, and then pick, say, a different 2 points, especially the one that has the one that's slightly off, I would notice that the slope of the 2 lines were different, which means the equation of those 2 lines would be different. So the question I'd have to ask myself, what we do when we find a mathematical model is we use information that we know to predict what's going to happen in the future. Is what would be a better thing to use to predict for what's happening in the future. What a linear regression does when we hit our calculator is it makes the adjustment for this point, and that means that our line's going to be slightly off, could be good or could be bad, but it's going to be a little off, but it kind of evens it out just a little bit. And it's called a line of best fit. In order to put a line in there, it says what's the line that best fits that. We saw that in the previous problem where we had this scattered data and we put a line through it. That was the regression line or line of best fit. That says, does that mean I have as much error on the top as I do on the bottom? That's kind of like the middle and balances it out. So that was our regression line for that particular problem. So as we continue on the next page, it says, now we want a linear model, and to model the data as best we can. We're actually finding the equation of the line that connects data points. So we're going to choose any 2 points. Doesn't matter which 2 we pick. We find the slope of the line, and remember, any 2 points, once we have 2 points, we can get the slope. Once we have the slope and one of those 2 points, I can find the equation of the line. That's why a linear model is so easy, because I just pick 2 data points, find the slope between those 2, have the slope, then pick one of those 2 points, I can find the equation of that line. So it's an easy model. If you're going to do a mathematical model, it's the easiest one to actually do. And I'm going to pick the first point, and I'm going to pick the last point, and you're going to say, well, why would I do that? Because that's what I feel like doing. I could pick the first and the middle, any 2 points. Now that means that if I were to ask you that question, I could have multiple answers, all that would be correct in this classroom, because some of you would pick different points. And if you pick different points, you could get a different slope. And if you get a different slope, that means you'd have a different equation of the line. So the 2 points I said I'm going to choose 2 points. I'm going to choose the first point, and which is 0, 128, 400. And I like this point. Why do I like this particular point? What's convenient about this point? Because x is 0, and if x is 0, what do I have in my hands? The y-intercept. So I can go directly to y equals mx plus b, which is nice because b is 28,400. And then I said I'm going to pick the last point, and the last point is 4,149,900. And then I'm going to find the slope. Well, the slope, if you remember, is the change in y divided by the change in x. So it's 149,900 subtract 128,400 divided by 4 minus 0. What I do is I always make sure, doesn't matter which point you put first, but I always make sure that if I were to cover up that the two numbers that are above and below each other are a coordinate point. 4, 149,900, 0, 128,400. That says slope means you have to have it in the right order. Doesn't matter which order, as long as the two coordinate points represent each other properly. And the denominator is easy. And the numerator, take my handy dandy little calculator and just use it like a calculator. 149,900 minus 128,400. And it's 21,500. And I think that's divisible by 4, and it is. And it's 5375. Now I can leave it in either form. And then the next question ends up being, what does that mean? We spend a lot of time in calculus on what does that mean? Well, the slope itself is what we call a rate of change. It's how fast or how slow something is changing. And when I look at the slope as being 5375 divided by 1, which is what it is, the units in the numerator are dollars because it's $5,375, and the units in the denominator is, X represents what? Years, right? And if we think of what the slope means, that says 1 year $5,375. So if I wanted to formulate a sentence, I would say for every, and this is one thing you want to have in your notes, year after 1998, the median price of a house does what? Increases. By $5,375. That's what the slope means. That says every year the price of the house. Now we know for sure the way things go. 1 year might be 53, but another year might be 43. Another year might be 57. But right now we're looking overall, given just 2 points, about 53.75. So if you were a house flipper, you probably wouldn't want to flip with those kinds of numbers. Well, why is that? Well, if you, since I'm a big, I watch HGTV and watch some of the flipping shows. What, they flip them in what, 3 months? and they put a lot of money into these houses. So you have to be very, 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 very careful that you're going to make money on it. Or the next question ends up being you don't want to overpay for a house either if this is the rate at which it's growing. So what happens in a hot housing market, which we had a few years ago, people were paying more than the price of the actual price of the house. They would bid it up. And so as a result, it would take how many years to recoup it if you overpaid? If it's only going up $5,000 a year. Around here, when we have a hot housing market, and we first moved here, we would look at a house, and then 3 weeks later, it would be like $5,000 more than what it was when we first looked at it. It's like, whew. And by the way, the units on this guy, if I were to look at units, and I'm going to put it up here because that's where I have space, because I'm going to always ask you to include the units. This would be 5375. Since it's dollars, I'll put the dollar sign. And then per, you could do it that way, year. Or you could say per year. Say it could be units per month. But when we're talking about a rate, miles per hour, that's a rate. We're talking about a rate, it's got units. Well, everything has units, as a matter of fact. It says find a mathematical model. This says equation of the line. That's all it wants. Mathematical model is just the equation of the line right now. Mathematical model could be a quadratic model, which is what we're going to study next. And that would be y equals ax squared plus bx plus c. But mathematical model. And it's easy enough because I know that the slope of the line is 5375. And I know the y-intercept is, whoops, lost it. The y-intercept is 149,900. 149,900. So y equals mx plus b says that y equals m 5375 times x plus, pardon me?
The first point B or the second one?
Oh, the first point is B. So it's 128,400, thank you. Where's my white tape when I need it? Who knows what I did with it? So I'm going to have to scratch this out. Ugly though it be. 120, thank you, 128,400. So 128,400. That's so that when x equals 0, then y equals 128,400. So that's your mathematical model. Just the equation of the line. That says now, if you wanted to predict the price of the median price in a house in the year 2010, right? You need to know what 2010 is with respect to 1998. 2010 would be what? So if I wanted to 2010, so 1998, this is x equals 0. So what would 2010 be? 12, yeah. I just plug in 12. Predict in the future, knowing what's happened in the past. But housing prices for models are, it's very, very difficult to do that.